Well, hello students and seekers of general truths. In that last video or last part of the lesson, we answered only one part of this question, right? How many revolutions does it take to turn 90 degrees? Done. But what about 60 degrees? Well, we can look at 90 degrees as our template for how do we do this work, and everything stays the same except for this part right here that says the car will rotate 90 degrees, and we had 90 over 360 times 25.7 pi. So if the car were to rotate 60 degrees, right? So if the car rotates 60 degrees, okay, then the wheels will travel a distance of 60 3/60ths times 25.7 pi inches, right? Because that's what we had last time. If you want the car to rotate 90 degrees, we use 90 over 360. And now, if we want the car to rotate 60 degrees, we just use 60 over 360, or 1/6. So working that out, we get approximately 4.283333, it's 3 repeating, pi inches. So that's how far the wheel traveled. And now once again, if we want the wheel to travel a distance of 4.2833 pi inches, and we want to convert that into revolutions, we'll put the units here, inches, and one revolution, keeping in mind, is equal to, same thing we had up here, you know, the size of the wheel hasn't changed, it's just 4 pi inches, so same thing here, 4 pi inches. In our unit analysis, inches will cancel out, and we end up with 4.28333 pi divided by 4 pi, and this gives me an answer of approximately 1.071 revolutions. Okay, so our units here are really, really important. All right, so comparing the questions that we just answered here, notice here that once we did all of the hard work for the 90-degree situation, now for the 60-degree situations, we can kind of piggyback off of that and, you know, just get just plug in 60 right here where we used to have 90. Okay? And so along those lines, let's take it a step further and generalize it to a point where all we have are variables. Okay, so let's say we had a car that has a width of W inches, the radius of the wheel is R inches, and it needs to make a simple turn of D degrees. Okay, so if the bird's eye view of the car is like this is the front, this is the brain, this is the back, right? And this length right here is W. So, and then again, just as like this is the wheel up here. These are our wheels up here, all right? And so when the car turns, right, it's going to make a turn this way, and the path that it will sketch out, well, it is a circle with a radius of W. Right? So if the car turns all the way around 360 degrees, then the wheel will travel a distance of the circumference of this circle. So this would be 2 pi times W. Inches, right? These are going to be our units. Okay. Now let's talk about the wheel. Well, the wheel, if it has a radius of R, right? So this is our wheel with a radius of R. Okay. Then the circumference of the wheel is going to be equal to, we'll say C is equal to 2 pi times R. Okay? So one revolution of the wheel produces a distance of 2 pi r inches. So we got the wheel figured out, we got the car figured out for a 360-degree turn. Now all we need to do is figure out, well, what if we don't want to rotate 360? What if we want to rotate some other number, like d degrees? So that means for a d degree turn of the car, okay, then the wheel will travel d over 360 times this distance, 2 pi times w. Okay? So if we just look back up here, d was 60 over here, so we had 60 over 360. And d was 90 up here, so we had 90 over 360. So that's the same thing as what we have down here. So let's put all of this together. We want the car to travel a distance of 2 pi dw over 360. Multiply, this is the distance in inches. This is the distance in inches. And again, we want to multiply by our conversion ratio, that one revolution is going to be 2 pi r inches. Okay? So our unit analysis, the inches will cancel out, and what we end up with is 2 pi dw all over 360 times 2 pi r. And you can see that the 2 pi on the top and the 2 pi on the bottom cancel each other out. And so all that's left here is the degrees that we have to rotate times the width of the car divided by 360 times the radius of the car. Of the wheel, excuse me. So d is the degrees that we have to rotate, w is the width of the car, and r here is the radius of the wheel. And so the number of revolutions that we need to rotate can be expressed as the follow. All right, thank you for watching. Keep working hard and keep thinking through these problems, and have a wonderful day.